Yes, folks, we come with the next video. Last problem, I think we finished till the 12th problem. Now we'll take the 13th one. 13th one is a simple problem. It says that a balloon, which always remains, again, spherical. So it has a variable diameter. They give you the diameter and they tell us that find the rate of change of volume with respect to x. So that's it. The diameter is given to us and they ask us to find out the rate of change of volume with respect to x, but that is dv by dx. So let's check now how we can do it. The diameter that's given to us, it is 3 by 2 2x plus 1. Diameter is 3 by 2 times 2x plus 1. We know that in the volume formula diameter doesn't play any significant role. It's a radius that's useful. So let's convert it into radius. You all know that radius is diameter by 2. So obviously your radius is going to be this divided by 2. Division by a fraction is multiplication by a reciprocal and so on. It will become 3 by 4 actually because you're dividing by 2. So this is your radius. They ask us to find out dv by dx. So let's see how we can do it. Therefore volume, because it's a sphere, we know it's 4 by 3 pi r cube and we require dv by dx. Here, it's dv by dx. So basically this is going to be 4 by 3 pi. Okay, I think we'll not jump directly. There's lots of work for simplification. So let's see this. 4 by 3 pi r cube means it is 3 by 4 into 2x plus 1 whole cube. First let's simplify this, then we'll go for the derivative. So this will come to 4 by 3 pi 3 by 4 3 by 4 into 3 by 4 and 2x plus 1 raised to 3. So in order to simplify this, probably 1 4 can cancel, 1 3 can cancel. You're left with 9 pi by 16 and 2x plus 1 raised to 3. Now you can get the derivative. Derivative with respect to x, 9 pi by 16 constant, no derivative. Derivative of the power first, then derivative of the base function. Anything raised to 3, we all know derivative for a power is always nx raised to n minus 1. So that way it is 3 times 2x plus 1 raised to 2 and then the derivative of the base. When you try to find the derivative of 2x plus 1, derivative of 2x plus derivative of 1, derivative of 2x is 2 into 1 because derivative of x with respect to x is 1. 1 is a constant, so it doesn't have a derivative. Basically, derivative of 2x plus 1 is 2. That's it. That's the derivative. They've asked us this. So it is 9 by 16 into 3 into 2 into 2x plus 1. The whole square. This is the derivative with whatever simplification. This is now 2 8s. That's all. Yeah. So your derivative is 27 pi by 8 into 2x plus 1 the whole square. That's the required derivative. They ask us what's the derivative and that is what your derivative is going to be like. They have asked us what is the derivative of v with respect to x and this is how the derivative works up like. So that's about it. Now we move to the next problem. Next problem is a very significant and important problem in the sense that it's been asked in the board exam and actually if you go to see, based on statistics, actually that's a problem that can be asked for a long question. There is quite a lot of things that you need to show, you have to find, and so on. So that way it is an important question. It has been asked in the board exam many times. So that's a good problem. So let's see what it says. The sand is pouring from a pipe at the rate of 12 centimeter cube per second. The falling sand forms a cone such that the height is always 1/6 of the radius. How fast is the height of the sand cone increasing when the height is 4 centimeter? So it's basically like this, that there is a pipe and from this pipe sand is falling. As it is falling, it is forming a cone. This is the scenario. Then what they say is the rate at which it is falling is 12 centimeter cube per second, means we all know that it is going to be dv by dt. By looking at the unit, it's so clear, right? So the rate of change of volume at which it's falling, it is that way. They also tell us that the height of the cone is 1/6 the radius of the base. Suppose say the height we plan to call it as h and the radius as r, then they say that height is 1/6 of the radius. That's another thing that they tell us. What else do they say? They tell us that how fast is the height increasing. Okay, so they are asking us how fast. So they are asking us dh by dt when h is 4 centimeter. This is the question. So everything is there. You are given dv by dt. You are given some things related to height and radius, and they ask us what is dh by dt. That's okay, because you know that the shape is a cone. You know its volume, right? You can use that volume and get all this. Okay, so with all this data in the background, we know that, yeah, what do we know? We know that volume is pi by 3 r squared for a cone. We have been learning earlier that we cannot take the derivative with respect to two variables. You have to restrict it to one variable. Because you have to restrict it to one variable, you have to make a substitution somewhere and see that it gets restricted to one variable. Then we can go in for the derivative. Here you've got r also variable, h is also. As the sand is falling, the radius and height, they both keep changing. So they both are variables. So you cannot find the derivative. It's difficult to find derivative with respect to two variables. So we'll restrict it to one variable. How? By making a substitution. Now how we'll substitute? We know that height is r by 6. R has to stay. H has to stay. Why? Because you have to find out dh by dt. So it's better we substitute r. So r can become 6h. This is as good as saying r becoming 6h. So we'll make that substitution. This is pi by 3, 6h squared into h. That means pi by 3 into 6 into 6 into h cube actually. So 2. So 12 pi into h cube. Since we have to find with respect to t, so let's find now derivative right away with respect to t. Derivative with respect to t here, 12 pi is a constant. Derivative of h cube with respect to h is 3h squared, and because it is with respect to t, we are writing dh by dt. Now let's try to have all the things, so we can make the substitution. So basically your dh by dt is going to be dv by dt by 12 pi into 3 into h squared. So let's make all the substitutions. dv by dt, we have it, it's 12. Here we have 12 pi, 3, and h for us is given as 4. That's it. Yeah. So you have these both cancelled, and it is 1 by 4 4 are 16, 48 pi centimeter per second. So the rate at which the height is increasing is 1 by 48 pi centimeter per second. So that's how it is, right? After we make all the substitutions and go in for the derivative. That's all for this video. I think we can have the next ones we can have in the next video. Thank you.